Now, this first one here, right in ascending order. We know it's about size. Which way is this? Is it smallest to biggest or biggest to smallest? It's smallest to biggest because ascending means going up in size. So they're increasing, okay? So you should have the smallest number at the front and the biggest number at the end, okay? Now, hands up straight. Who agrees? Yep. Show of hands. Wonderful. Thank you. Hands down. This one has some clues in it, right? You can see what I've tried to do to make this a little bit more different to the way you normally see this, is I've provided these numbers in different forms. Yes? What's this called? It's a decimal. This is a percentage. This is a... Okay, but they're all different ways of talking about the same kinds of objects. Okay? Now, we can know quickly that 0.099 has to be the smallest. Why? Yeah, Ryan. Yeah, that guy says, you know what, compared to all these guys, he's tiny. It's like 10 times smaller than all the rest of them, okay? So that's the first thing I note. When you compare these two, okay, hands up, how did you know that 9/11 was smaller than 90%? Any takers? Any takers? Someone else? Yeah, Brian, what'd you say?
You converted it.
What did you convert into what?
The decimal.
Which one? Hold on, I'm looking at these two, yeah? I'm trying to work out which one is bigger. Danielle, what did you do?
Because 90% is 9/10 compared to the 9/11.
Okay, fantastic. Yeah, very good. So, one of the tricky things about this question is, because they're all talking in different languages, at some points you're going to have to do some conversion. But some conversions are easy, other ones not so much. So 9/11, for instance, you could convert that into a percentage. There's nothing stopping you. But it's a very inefficient way to go about it. Like, it's much simpler just to say, well, I can turn this into a fraction. 9/10, that's got to be bigger than 9/11, right? Like, you're taking the same stuff, that's the numerator, and you're dividing it into more chunks or less chunks. What about this last one? How did you know that was the biggest? Yeah, Isabel.
90.9%.
Yeah, very good. Whoops, sorry. So if you again do another conversion, right, you can see actually the comparison is quite easy to make, so thumbs up. Okay, now let's have a look at the equation in the middle. The answer I'm seeing here from Jennifer, I think, is x equals -9 on 13. Show of hands for who agrees with that. Okay, this is interesting. Hands up straight. Hands up straight. Okay, I see a few hands. Hands down. I see a few hands, but not that many. So I want us to work out whether this is right or not, and whether we can convince ourselves one way or the other. Now, this step is really important. We need to look at, and Jennifer's very helpfully given us some lines of working. We need to look at each line and try and work out what's going on. Okay? Line 1 to line 2. From the question to Jennifer's first line of working, what's she done? Hands up, someone non-Jennifer to explain what she's done. Yeah, Kushi, what would you say?
She's like cross multiplied in a way.
Okay.
With the denominator, so 5 times 3x plus 1 and 2 times x minus 2.
Yeah, okay. So I'm going to give a thumbs up to that. This idea of cross multiplying is a very efficient way to go about this. Can I just get you to put your pens down there for a second? And I want you to be cautious with this. Here's why. I'm actually teaching something very similar to this in my Year 11 class at the moment, and it's really easy to confuse cross-multiplying with something that's very similar but different. Let me show you what I mean. If I asked you to solve that, that's another equation. It's got more x's and more fractions. Algebraic fractions is what we call them. Andrew. Now it's very tempting to look at this question and say, oh, look, a pair of these fractions, I know what to do. I am going to cross multiply. So you do this and this, okay? And I frequently see students, year 11s and 12s, write this as they're working. They cross multiply, which gives them that, and they say that's that. 5 plus 3, that's 8x. And so x equals, really? I'm dividing both sides by 8, right? So I'm pretty sure that's a quarter.
What?
2 divided by 8? 1 over 4. Yes, are you with me? I know it's warm, but the brain's still operating, right? Okay, now, it all looks so nice and convincing. It sounded great, except for one glaring problem, Ryan.
The denominator of the 2 is a 1 and you didn't make that the same denominator as the other denominator.
Okay, so this denominator over here, right? This is so important, which is why I'm making a big deal out of it. People often will cross multiply, but not really know why it works. I'm going to suggest something different. I actually would prefer you not to say cross multiply, even though that's exactly what it looks like and it so nicely gives you the answer. I think that is the answer. What you're really doing, and on your line of working, whatever you have done, I'd like you to add this instead. On the original line, what we've done, what Jennifer's done, is she has multiplied this by 10, and since it's an equation, if you do something to one side, then you'd better do it to the other. Do you agree? So therefore this guy also gets multiplied by 10. Okay? Now, I wonder if you can see the problem therefore with how I did this. You put in a quarter, you will not get the solution. Okay? X on 3 turns into 5x. What if I multiplied it by to do that? X on 3 turned into 5x. I think I've multiplied it by 15. Do you see that? 15x over 3 is 5x, isn't it? 15x over 3, you cancel, and that leaves you with 5x, right? What about this? What do we multiply this by to get to that? Again, it's 15, because 15x over 5, the 5 cancels, it leaves you with 3x. Wait, hold on a second. If you multiply these by 15, then shouldn't you multiply something else by 15 as well? So this guy over here ought to become 30. That's why x equals a quarter is not the answer. Okay? So rather than saying cross multiply, I'm going to encourage you to think about what is it you do to both sides. Okay? What is it you do to both sides? Someone? No. Okay. Whoa. Keep forgetting that there. Okay, so after that, are you convinced by the working? She has multiplied both sides by 10. What did she do after that? Can you describe to me in words what she's done from here to here? Yeah, okay. What? Yeah? Yeah, well, give me a sec, hold on. Someone help him out? Anyone help him out? Yeah, still. Do you want to try it now? Yeah?
Yeah, she did do it. So she brought the 15x to the right and left side. So if it comes to x minus 15x.
Okay? Yeah? Really? Hold on. Careful. Now again, let me help out here. Okay.
So she brought the 2x.
Yeah, okay, so watch out here. I'm hearing a lot of language, and as you guys were doing the questions, I heard this as well. Just like I think talking about this as cross-multiplying is dangerous, kind of works if you know what you're doing. Rather than saying I took in this case, 2x, I took it to the other side, and then when I took it over, it became negative. What Jennifer really did is she subtracted 2x from both sides. Do you see that? The same operation, done at the same time. That's why 15x becomes, there's the leftover, okay? And then you proceed. That's the right answer. Lastly, 18 square centimeters, thumbs up. Thumbs up, yes? Okay, wonderful.